right? So when you do these piecewise functions, right, we came down, you started here, you came down, and then went to here, but then you picked it up, okay, and then ended here, all right? You don't pick it up like at this point right here because it includes the decimals. It has to go, in this case, all the way to 1, okay? It has to be connected if they are connected, okay? Sometimes, you'll have one here, and the next one will pick up here, okay? No big deal. So if I plug in 1 to the top one, what do I get? -3. If I plug 1 to the bottom one, what do I get? -3. Okay? -3, -3. So that means that the limit is -3. Okay? Which one would have a hole, so to speak, and which one would be colored in? The top one would be colored in. The bottom would be the hole gets colored in by the other one. All right? The next one, what happens? Zeros, undefined. Okay, because you get zeros in the denominator. Okay, we might say, oh, I get zeros or whatever. Okay, remember, you're only concerned with what goes on in the denominator. Okay, so when that happens, now you have to be very careful of this. Okay, we're approaching 2. So I have my x value, and I'm going to use 1, 1.5, 1.7, and then remember 3, 2.5, and 2.2. Okay, so go ahead and try that. Right, this top one are all values greater than or equal to 2. So that means in the top one, you would plug in the 3, the 2.5, and the 2.2, okay, to see what it's approaching. The bottom one, you would plug in, because it's less than 2, you would plug in the 1, the 1.5, the 1.7. Okay? So at the x minus 2, okay, so the value of 2, since it doesn't cancel, it's going to be an asymptote. All right? Now, if you are unsure of the 1.7, so then you might put in 1.8, 1.9, 1.99, 1.999. Okay? Gee, I don't know. I only have 2.2. Go ahead, put a 2.1 in, a 2.001, whatever. Okay? To be more accurate. So what's happening here, they both are approaching infinity. Okay? Okay? Now you get something like example 11. X equals 0. You plug 0 in, and it's going to be undefined. Okay? So you don't want to get mixed up with this one. You're like, oh, what the heck am I doing here? So you just go right to, you're not going to worry about factoring anything with a radical. I'm going to show you a variation of the radicals in a minute. Okay? So you would just plug in values for this, and you would come from the left and come from the right. Okay? Be very, very careful with this one. So what are you getting for outputs as I approach it from the left side? As I get closer, closer to 0, what are you getting? Like 0.3? What? What are you getting? You should have done it. From the left side, you should be getting, okay, I'm going from the left side. I'm doing like -1, -0.5, -0.2, -0.1, okay? So if you chose like -1, you're getting like 0.41, right? Then 0.37, 0.36, 0.35 something, right? You're getting closer and closer. All right, now, coming from the other side, I'm getting like 0.34, 0.33, 0.32. Oh, I'm sorry, the other way around, because I'm going from 1. 0.32, 0.33, 0.34, okay? Closer and closer to what? 0.35. Sure. Now I say, oh, geez, let's do x equals, I'm getting closer to 0, so I want a negative 0.001. Enter. Oh, what happened here? What's that? Oh, thank you. Yeah, I have an X instead of a 2. Okay. So underneath here, that's got to be a 2. Enter. Boom. Okay. 0.3535, right? Okay, gee, I'm still not sold on that. So what do? I just go, I don't want that. I just go and I plug in another. See, look, it's getting closer. See how ever slowly or slightly it's moving towards it? Okay. And then if I choose the positive direction, so maybe I do 0.001, okay, I'm also 0.3530, okay, and then I throw in another couple zeros, okay, and you see how it's getting closer to 0.35 on both of them, okay. Sometimes it's 2 decimal places, sometimes it's 3, okay, sometimes it's 1, all right. So like if you're approaching 1/2, that's a 0.5, okay. So it gets a little tricky when you get into some of these more complicated problems. Okay, does that make sense? Okay. Now the last page that I'm going to do in the notes are limit, positive and negative infinity. Okay? So what happens here is f of x will be a fraction. Okay? Every single one of these, the f of x is a fraction. Okay, to apply these rules. Okay? When they are written as a fraction, you want to put them in descending order. Okay? And the only thing we're worried about is the power function. If you remember from Algebra 2, the power function is a single term. So if I have, in example 13, if I have that numerator, 4x cubed minus 5x squared plus 3x minus 1, the power function is 4x cubed because that will decide the end behavior. Okay? So if it's an x cubed, that means that it goes in opposite directions. As x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches infinity. Okay, because of the higher power. The other thing, just is it stretched, is it compressed, whatever. Okay, how many intercepts are there? Okay, there has to be at least one. All right, so does that make sense? You're looking at the highest power. So if the highest power of x, okay, it's bottom heavy, then no matter what, it approaches 0. Okay, so the limit as x approaches positive or negative infinity, f of x will equal 0. Okay, the limit of f of x. All right, that means it's bottom heavy. All right, number 2, if the highest power of x appears in the numerator, then it's top heavy, it's either going to positive or negative infinity. And what do? You plug in very large or very small numbers to determine the sign of the answer. Okay, so you plug in 1,000, 2,000, whatever. Okay, negative 500, negative 1,000. You just plug a couple values in. And finally, if the highest power appears in both the numerator and denominator, then what you do is you just kind of throw away the variables. So it's just the coefficient of the numerator's highest power over the coefficient of the denominator's highest power. Okay, so that's all we're focusing on. Okay, so example 12. You'll be able to refer to these rules on your first quiz, okay, just to help you with them, because I know it's tricky and there's a lot to know. Okay, so the first quiz or two, you'll be able to use these notes, okay, to help you out, to guide you along, because I know we've done a lot. We've only done 2-1-2-2, and that's it. Okay, so there's a lot going on here. Okay, so like I said, this stuff here, this doesn't matter. Who cares? Okay, all that does, like I said, it might expand it, whatever. Okay, it just affects it a little bit. These are the key things. The end behavior with these are the important parts of it. Okay, so we say what? The highest power appears in the denominator. Therefore, the limit as x approaches infinity is 0. Rule 1. That's it. Okay. Example 2. Key thing, make sure they're in descending order. Is this in descending order? Yes, it is. Same thing here. No worry, no worry. Those additional terms have nothing to do with the end behavior. Nothing at all. Okay? So now we look at these two. The powers are the same, which is rule number 3. Therefore, it 4 or 5. That's it. Okay. Last one. 3x cubed minus 23 over 4x minus 1. The highest power appears in the numerator. Therefore, it's going to be top heavy. So we have to plug a couple values in. Okay. So let's plug in 10 and plug in 100 because it's approaching positive infinity. I got whole numbers unless I rounded it. What'd you get? I got like 76. Yeah. So okay. So if it's decimal, I would go to decimals then. All right. Because if you're looking at 123 over 7, you're like, what the heck is that? You know what I mean? So I do because I'd be like, as I say, oh, it's 76. Bam. I know right where that is. Okay. As opposed to saying 1200 divided by 23. I don't know where that is. Okay. I got to do a little more work. Yeah. So make them decimals. Okay. I see what you're saying. And then when you put 100 in, what'd you get? 7,500, right? Okay. So all we're worried about is just a rough estimation. So I go 76 to 7,500. So where do you think this limit's going to? Going to infinity. Okay. That's fine. When you're plugging in values, it doesn't matter because you're just trying to get a general idea of where it's going. Okay? So like if you have 4.5 and you make it 5, no big deal because the next one's going to either be, 35 or it might be negative. Okay? Because you could have an asymptote that's higher up on the y-axis. Okay? It could happen. Okay? All right, now this one is kind of tricky here. This example 15. We have a complex fraction. Okay? So we don't like complex fractions. All right? So what has to happen here is we have to change this so that the complex fraction is eliminated. So the first thing I would do is I would rewrite it like that. Why do I rewrite it like that? Because that's in descending order. Okay? Now, a negative 5x squared. I don't care what's in front of the x squared or the highest power. It doesn't matter. The only thing that changes is, right, this is an x squared, yes. That's a negative x squared, right? Okay? So end behavior stuff has to come back to us. All right? This is an x squared or an x cubed, right? That's an x cubed, right? This is a negative x cubed. Okay? And this holds true for all even. This holds true for all odds. Okay? So if I have this in my numerator, this is technically over 1. Okay? And then I take this right here, and I have to invert and multiply. Because it is that numerator all over the denominator. The denominator is 1 over x. If it was not, this line would be longer between the 1 and the x. Okay? But since it's just a small one, that means that 1 over x is a fraction in the denominator. Okay? So that means that this becomes that. Negative 5x cubed plus 4x squared plus 3x. Okay, now we have a basic, polynomial that you should know. Okay, so like I said, x cubed is like this. Negative x cubed is like this. So as x approaches negative infinity, what does y approach? Infinity. Okay, if you still need to plug values in, that's fine. You can plug values in, not a big deal. Okay, if you don't know the end behavior. Okay. What's that? Yeah, oh yeah, yep. Okay. Yeah, if it ever comes up on a quiz, or a test where you don't know if it's a positive or negative, just ask me. Positive or negative. Sometimes even the typing on the quizzes I make up is a little weird. What they do, they just have a little bit of space. Okay, so anyways, all right, what happens here? All right, examples 16, 17 are the same thing. One's positive, one's negative. Okay, now, very similar, like that. Okay, now, if I take the square root of x squared, you have to be very careful. So we're going to be able to plug all these values in to see exactly what's going on. Okay, but the rule is, okay, the square root of x squared equals what? X. Okay, the square root of x squared equals x. But what you have to consider is I can plug in into my x value a positive or a negative and still end up with an x. Because if I have a negative 2 squared, it's going to give me 4. Square root of 4 is 2. If I put a 2 in, 2 squared is 4. Right? Square root of 4 is 2. So you have to consider both. That's why we have the positive and the negative. Okay? So for this intent's purposes, so this would be x over 2x, which would be 1/2. And because this is an introductory one, this is more basic. Okay? This is approaching the positive 1/2, and you could prove it by plugging values in. This one here would be x over 2x the same way, but this one approaches the negative 1/2. For this basic one. Okay? The more complex ones, you would just put a couple values in to prove. Okay? But that's where it's getting. So you're getting at the 1/2. So remember like the earlier one we did? You got 0.3635. Oh my God, what's it approaching? Well, I don't know. This one here, at least you know it's approaching 0.5. It could be positive, could be negative. Could be switched. Negative doesn't always go with negative. Okay, positive doesn't always go positive. Okay? And I think that's it. All right, so what I wanted to do before I give you guys the work is I just wanted to take a look at a couple of these earlier ones that we showed, we proved. I want to put them in the calculator. All right, so that's all we're going to do is we'll put them in the calculator.